Welcome back to the Nocturnal Astronomer. I'm your host, Atlas Reed. Tonight, I have something strange to share before we even begin. High above the clouds of a nearby planet, at the right altitude, the pressure and warmth are close to what you feel on a mild Earth afternoon. A gentle layer floating above a furnace. This evening, we travel to Venus, the second planet from the Sun and the closest full planet to our own. We will board a ship, leave Earth behind, and drift quietly through open space until a bright new world fills the window ahead of us. Venus is often called our sister world, close to Earth in size and shape, yet its surface hides one of the harshest known places in our solar system, beneath clouds that shine brighter than any other planet in our night sky. We will move through this slowly, calmly, one gentle layer at a time. Let's dive in. Part 1. Boarding the ship. You step aboard the ship through a quiet corridor lit softly in blue. The hum beneath your feet is steady and low, almost like breathing. A gentle voice confirms the doors are sealed. Ahead of you, a curved window shows Earth, still resting calm and blue against the dark. You settle into your seat. The countdown is soft, almost a whisper, counted down by a calm voice at your side. There is no shaking, no roar, only a gentle press into your seat as the ship lifts free of the ground. Within a few minutes, the sky outside turns from pale blue into a deep, endless black. Below you, Earth begins to curve away, its edges softened by a thin blue haze of air. Clouds drift slowly across oceans and green land, and for a moment you can see the whole shape of home in a single calm view, quiet and whole, framed by the dark beyond it. The ship steadies itself and begins its long, gentle push toward the sun. Venus sits closer to that light than Earth does, so the journey ahead will carry you inward, toward warmth rather than away from it. The engines settle into a low, steady tone that fades into the background of your mind. Outside the window, stars hold perfectly still, neither rising nor falling, since there is no longer any ground beneath you to give them motion. You may notice how quiet true space feels, without air to carry sound. Every hum you hear comes only from the ship itself, close and familiar. Days pass gently aboard the ship, marked only by soft lighting that dims and brightens to hold a calm rhythm for your body. You drift between rest and quiet thought, watching the black beyond the glass, where a few nearby stars begin to shift ever so slightly as you move. The ship's course bends gradually inward, following a wide, patient path that scientists call a transfer orbit, a calm curve that saves fuel by letting gravity do most of the guiding. There is no need to rush. Venus will still be there, waiting quietly, wrapped in its pale golden light. Somewhere in the middle of the journey, Earth becomes a small, pale point behind you, and for the first time, you may feel the true scale of the space between two worlds. It is not frightening, only vast, a calm reminder of how much room the solar system truly holds. As the days continue, a soft golden light begins to grow ahead of the ship. Faint at first, then steadier, like a lamp being slowly turned up in a quiet room. This is Venus, wrapped entirely in cloud, reflecting far more sunlight back into space than our own homeworld does. By now, the ship's course has settled fully toward its target, and the crew, mostly quiet machines and calm systems, prepare gently for arrival. You watch the golden light ahead grow steadily larger, filling more of the window with each passing hour, calm and bright and closer than before. Part 2. Arrival at the second planet. The ship slows gradually, easing itself into a wide path around Venus rather than rushing toward it. Outside your window, the golden light no longer looks like a distant point. It now fills the whole view, soft and glowing, curved gently like the edge of a great pale lantern. From this distance, Venus shows no oceans, no green land, no dark patches of any kind. Instead, a smooth, pale yellow blanket of cloud covers the entire planet from pole to pole, hiding everything beneath it. It is one of the most reflective worlds in our whole solar system. This brightness comes from thick clouds made largely of sulfuric acid droplets floating high above the surface. These clouds bounce back most of the sunlight that reaches them, which is part of why Venus can outshine every other planet in Earth's evening or morning sky, second only to the Sun and Moon. As the ship settles into orbit, you notice something calm and strange. There is no sign of weather in the usual sense, no storms shaped like the ones you might picture from home. Instead, the clouds move as a single steady sheet, calm on the surface, yet swift high above. Beneath this pale ceiling, hidden from view, lies a surface shaped by ancient lava flows and gentle highlands, a solid rocky world, close in size to Earth. Venus measures roughly 12,104 kilometers across, only slightly smaller than our own home planet, yet utterly different beneath its clouds. Scientists sometimes call Venus Earth's twin, because of this shared size and similar rocky makeup, both worlds forming from the same early cloud of dust and gas that built our solar system. Yet the paths these two planets took afterward could hardly have grown further apart from one another. As you orbit quietly above the clouds, sunlight scatters softly across their surface, giving the whole planet a gentle glow, almost like moving above a calm sea of pale gold. It is easy up here to forget what lies beneath, a place shaped by heat far beyond anything found on Earth. The ship holds a steady, patient orbit, giving you time to simply watch. Occasionally, faint patterns ripple slowly across the cloud tops, shaped by streams of moving gas that circle the entire planet in only a few Earth days, far faster than the ground below ever turns. Venus has no moon of its own, unlike Earth, and none of the smaller icy bodies that many outer planets keep nearby. Up here in orbit, the sky beyond the clouds is simply dark and quiet, holding only distant stars, the sun, and far off a small pale blue point that is home. For now, we simply rest in this calm, high orbit, taking in the golden light before we begin to look closer at what lies far below the clouds in the heated, pressed-down world that gives Venus its true and remarkable character among all the planets we know. Part 3. A thick and heavy sky. The air around Venus is unlike anything found on Earth. It is made almost entirely of carbon dioxide, more than 96 parts in every 100, with only a small trace of nitrogen mixed in. There is no oxygen to speak of, and no water vapor drifting through it at all. This atmosphere is also remarkably heavy. Near the surface, its weight presses down with a force about 92 times greater than what you feel standing on a beach on Earth. It is closer to the pressure found deep beneath our oceans than anything felt on solid ground back home. Carbon dioxide is very good at holding on to heat, trapping sunlight that would otherwise bounce back out into space. On Venus, this effect runs stronger than anywhere else nearby, wrapping the whole planet in a thick, invisible blanket that keeps warmth pressed close to the surface at all times. Scientists call this process the greenhouse effect, the same gentle warming that helps keep Earth comfortable in a much smaller way. On Venus, though, this effect has grown far beyond a gentle warming, turning a planet that should be only mildly warm into the hottest surface in our solar system. There is a quiet lesson tucked inside this thick sky, showing how a small shift in a planet's air can lead to an enormous change in its surface over a long stretch of time. Venus offers scientists a close, real example of how a planet's atmosphere can shape everything beneath it. High above the ground, this dense air also bends and scatters sunlight in gentle, sweeping patterns, giving the sky above the clouds a soft golden colour rather than the pale blue we know from home. From orbit, the whole planet glows evenly, wrapped fully in this warm, steady light. Unlike Earth, Venus holds no large seasons shaped by tilt, since its axis leans only slightly compared to its path around the Sun. The heavy air itself, rather than any seasonal shift, is what shapes conditions across the whole surface, keeping temperatures remarkably steady from one place to another. Near the very top of this atmosphere, far above the clouds, the air thins out gradually until it fades into the emptiness of space. It is here that a ship can pass safely, riding just above the layers where sunlight and heavy gas meet in a long, gentle transition. If you were to release a balloon from the ship right now, it would drift downwards, slowly at first, then sink faster and faster as the air around it grew steadily thicker and warmer, eventually reaching pressure and heat that few instruments have ever survived for very long. For now, we stay high, letting this thick and heavy sky remain a calm and distant idea rather than something felt directly. Ahead of us lie the clouds themselves, the pale golden layer that gives Venus its brightness, and beneath them a surface shaped by heat beyond anything on Earth. Part 4. Clouds of Pale Gold. The clouds that wrap Venus sit high above the surface, stretching from roughly 48 kilometers up to about 70 kilometers in altitude. Within this wide band, they form a nearly complete covering, hiding the ground from view no matter where a ship might look down from orbit. These clouds are not made of water, as clouds on Earth mostly are. Instead, they are built largely from tiny droplets of sulfuric acid, mixed with a small amount of water vapor. It is a strange and quiet fact that the softest-looking clouds in our sky hide something so sharp. Sunlight striking these droplets scatters and reflects with great efficiency, which is why Venus appears so bright from Earth and why the whole planet glows so evenly from orbit. Very little sunlight manages to pass all the way through this layer, down to the rocky ground far below it. Near the cloud tops, the atmosphere moves swiftly around the planet, circling fully in only about 4 to 5 Earth days, even though the solid ground beneath turns far more slowly. This fast movement high above creates long, streaking patterns that early observers first noticed through simple telescopes. Lower within the clouds,
conditions grow steadily thicker and heavier, with several distinct layers stacked one above another. Each layer holds slightly different temperatures and droplet sizes, forming a tall, gentle column of cloud that scientists have studied carefully using orbiting spacecraft and careful remote instruments.
Beneath the lowest clouds lies a hazier layer, thinner and calmer, extending down toward the surface. Sunlight that reaches this point has already been softened and scattered many times over, leaving only a dim, orange-tinted glow to filter through toward the hot, rocky ground far below it. Lightning has also been detected within these clouds by several spacecraft passing near Venus, brief flashes of light moving through the thick, acidic layers high above the surface. Scientists still study this activity closely, comparing it carefully with the lightning familiar to us from storms here on Earth. Because of their brightness and their reach, these clouds are the true reason Venus can be seen so easily without any instrument at all, shining steadily just after sunset or just before sunrise, often mistaken by early observers for a bright, low-lying star hanging near the horizon. From our quiet orbit, the cloud tops below look calm and unbroken, a soft golden sea stretching to every horizon. It is easy to forget, gazing at something so gentle in appearance, that the layer just beneath it holds one of the harshest known surfaces in the whole solar system. Soon, we will begin to look past this golden covering toward the surface itself, where heat and pressure combine in ways that have shaped Venus into the most demanding world that any spacecraft from Earth has ever managed to reach and briefly study up close. Part 5. The hottest ground we know. Beneath the clouds, the surface of Venus holds a temperature of about 467 degrees Celsius, steady both day and night, across nearly the entire planet. This makes it the hottest surface of any planet in our solar system, hotter even than Mercury, which sits far closer to the Sun. This heat comes almost entirely from the thick blanket of carbon dioxide above, trapping warmth so effectively that very little of it can ever escape back into space. Even the long, slow nights on Venus bring almost no relief, since the heavy air holds its temperature steady around the clock. At this heat, several metals that stay solid on Earth would soften or turn fully liquid on the surface of Venus. Lead, for example, melts at a much lower temperature than this, meaning it would pool and flow gently across the ground rather than remain a solid piece of metal. Alongside this heat, the pressure at the surface presses down with a force close to 92 times what you feel on Earth, similar to conditions found nearly 1 kilometre beneath our own oceans,
Together, heat and pressure make the surface one of the most demanding places any machine has visited. No liquid water exists anywhere on this surface today, and scientists believe none has for a very long stretch of time, since the heat alone would cause any water to turn instantly into vapor. Some early evidence suggests Venus may once have held oceans, long before its atmosphere changed so greatly.
This shift is often described as a runaway greenhouse effect, a slow, steady build-up of heat trapped by carbon dioxide that eventually pushed temperatures far beyond anything mild. It stands as a careful reminder of how gradually an atmosphere can reshape an entire world over a long stretch of time. Despite this heat, the surface itself is solid rock, shaped by ancient lava, rather than sand or soil in the way we might picture from Earth. Wide, flat plains stretch across much of the ground, formed long ago by lava that spread out evenly before slowly cooling and hardening in place. Very little sunlight reaches all the way down through the thick clouds and hazy lower air, leaving the surface dim, glowing faintly in an orange tint rather than bright daylight. Photographs taken by landers show a soft, hazy horizon, calm in appearance despite the fierce heat surrounding every surface and stone. Sound itself behaves differently in air this thick, traveling more slowly and carrying farther than it would through Earth's thinner atmosphere. Any noise made near the surface of Venus would likely sound low and heavy, shaped entirely by the dense, pressing weight of the air moving gently around it. We will not land here tonight. Only imagine it from a careful distance, letting the heat and pressure remain a quiet fact rather than something felt directly, as we turn instead toward the shapes rising from this surface, the highlands and volcanoes that mark Venus as a truly active world. Part 6. Mountains and Ancient Lava Fields. Venus holds more volcanoes than any other planet in our solar system, with over 1,600 large ones mapped across its surface, alongside many smaller ones too numerous to count individually. Most of these formed from slow, steady eruptions of thin, flowing lava, rather than sudden, forceful blasts. Rising above the plains, tall highland regions break up the otherwise smooth surface of Venus. The largest of these is called Aphrodite Terra, a broad, uneven stretch of raised ground roughly the size of Africa, wrapping partway around the planet near its middle, shaped by ancient movement deep beneath the crust. Farther toward the northern reaches lies a smaller highland called Ishtar Terra, roughly the size of Australia, holding within it the tallest feature anywhere on Venus. This mountain range, named Maxwell Montes, rises about 11 kilometers above the average surface level,
taller even than Mount Everest back on Earth. Between these highlands stretch wide, flat lowlands, covered almost entirely by ancient lava that once flowed freely across the surface before cooling into place. These plains make up most of Venus, giving the planet a surface that looks, in careful radar images, remarkably smooth compared to rockier worlds nearby. Because thick cloud hides the ground completely, scientists have relied on radar to map Venus in detail, sending signals down through the atmosphere and reading the shapes that bounce back. This method revealed mountains, plains, and craters that no camera could ever capture through such a heavy golden covering. Craters on Venus tend to be fewer and generally larger than those found on similarly sized worlds, since the thick atmosphere slows and breaks apart many smaller pieces of rock before they ever reach the ground. Only the sturdier ones survive the long fall down through such dense, heavy air. Some regions of the surface appear younger than others, suggesting that lava has resurfaced parts of Venus more recently than once believed. Certain hotspots detected by orbiting spacecraft hint that some volcanoes may still be active today, quietly reshaping small areas of ground beneath that thick golden sky. Unlike Earth, Venus shows little clear evidence of shifting crustal plates sliding against one another over time. Instead, scientists believe its surface may renew itself in slower, broader waves, with heat building beneath the crust until it finds new pathways upward through cracks and gentle openings across the ground. Studying these highlands and lava fields helps scientists understand how a rocky world close in size to Earth can still develop such a strikingly different surface. Venus offers a careful comparison, showing what our own planet might resemble without the moving plates that constantly reshape ground here at home. From high above, none of this detail is visible to the eye, only the calm golden clouds drifting steadily below the ship. Yet, knowing what lies hidden beneath, ancient mountains, wide lava plains, and volcanoes still possibly active, adds a quiet depth to the gentle golden view outside our window. Part 7. A day longer than a year. Venus turns in a way unlike almost every other planet in our solar system. While most planets spin in the same direction that they travel around the Sun, Venus spins the opposite way, a pattern scientists call retrograde rotation, quiet and unusual among the worlds we have studied so closely. This backward spin is also remarkably slow. One full turn on its axis takes about 243 Earth days to complete, longer than any other planet in our solar system needs for a single rotation, making a single Venusian day stretch far beyond what we experience here at home. Even more curious,
Venus takes only about 225 Earth days to travel fully around the Sun. This means one day on Venus, measured from sunrise to sunrise, is actually longer than one full year on Venus. A gentle contradiction that still surprises many people hearing it for the first time. Because of this backward spin, if you could somehow watch a sunrise from the surface, the sun would appear to rise in the west and set in the east, the exact opposite of what we experience on Earth. A small, quiet detail that flips a familiar pattern entirely on its head. Scientists are still studying why Venus spins this way, with several careful ideas offered over the years. Some suggest an early impact long ago may have tipped its spin, while others point to the thick atmosphere itself, gradually shifting the planet's rotation through steady, gentle pulling over a long stretch of time. This thick atmosphere plays an especially interesting role, since it moves independently of the solid ground beneath it, circling the entire planet in only about 4 to 5 Earth days. The upper air races ahead of the surface far below, creating one of the more puzzling patterns found on any known world. Because the rotation is so slow, Venus also barely bulges at its middle, unlike faster spinning planets that flatten slightly at their poles. Its shape stays remarkably close to a perfect sphere, one more small way that this steady, unhurried spin quietly shapes the planet's overall structure. This slow turning also means there is very little difference between day and night in terms of temperature at the surface, since the thick atmosphere holds heat so evenly across the entire globe, regardless of which side currently faces the sun during any given stretch of its long Venusian day. Venus has no moon to help slow or steady its spin the way Earth's moon gently does for us, leaving its rotation shaped instead by its atmosphere, its interior, and whatever early history first set this backward, unhurried pattern into motion so long ago in the solar system's youth. As you drift above the golden clouds, it is worth pausing to imagine a place where a single sunrise to sunrise stretches outlasts an entire trip around its star, a gentle reminder of how differently time itself can pass from one world to another across our solar system. Part 8. Reaching Venus from Earth. Venus has been visited more often than almost any other planet, with dozens of missions launched toward it since the early 1960s. Much of this early exploration came from the Soviet Union's Venera program, a long, patient series of spacecraft built specifically to study this bright, cloud-covered world. Early Venera missions struggled against the extreme heat and pressure waiting below the clouds, with several spacecraft stopping their signals before ever reaching solid ground. Engineers studied each result carefully,
adjusting their designs with every attempt, slowly building spacecraft tough enough to survive conditions far harsher than expected.
In 1970, Venera 7 became the first spacecraft to send data back from the surface of another planet, briefly surviving the crushing pressure and heat long enough to confirm just how demanding conditions truly were before its signal finally faded beneath that thick golden sky. Later missions in the Venera program managed to send back the first images from the surface of Venus, revealing flat, rocky ground and a soft, hazy horizon glowing faintly orange. These images remain some of the only direct photographs ever taken from the ground of this challenging world. The United States also studied Venus closely, sending the Pioneer Venus missions in the late 1970s to orbit the planet and drop several small probes down through its atmosphere. These probes gathered detailed readings of temperature, pressure, and composition as they descended slowly through the thick, heavy clouds. In the 1990s, a spacecraft named Magellan arrived at Venus and spent several years mapping nearly the entire surface using radar, seeing clearly through the clouds that had hidden so much for so long. This mission gave scientists their most detailed picture yet of mountains, plains, and volcanoes below. More recently, spacecraft passing Venus on their way to other destinations have paused briefly to gather additional readings, using the planet's gravity to adjust their own path while quietly adding to what scientists understand about its atmosphere, its clouds, and the surface hidden so completely beneath them. Missions to Venus remain especially difficult because so few instruments can survive its surface conditions for very long, even briefly. Most landers have functioned for only an hour or two before the heat and pressure proved too much, making every reading gathered there especially valuable to scientists back on Earth. Newer missions are now being planned, aiming to study Venus's atmosphere, its clouds, and hints of possible ongoing volcanic activity in far greater detail than before. Some proposals even imagine balloons floating gently within the calmer upper clouds, riding above the harshest heat while still gathering careful, steady readings. Each mission adds another quiet piece to a picture built slowly since the 1960s, turning Venus from a bright, mysterious point in our sky into a planet we now understand in careful, patient detail, layer by layer, cloud by cloud, and reading by reading across many decades of study. Part 9. The brightest point in our sky. From Earth, Venus is often the brightest planet visible to the naked eye, outshined only by the sun and the moon. It appears either shortly after sunset in the western sky, or shortly before sunrise in the eastern sky, never straying far from the sun as we see it from home.
Because of this pattern, Venus earned two gentle nicknames long ago: the evening star when it appears after sunset, and the morning star when it appears before sunrise. Ancient observers in many cultures once believed these were two different points of light before realizing they were the very same planet. Venus shows phases much like our own moon does, shifting gradually from a thin crescent to a fuller, rounder shape as it moves along its path around the sun. Galileo Galilei first observed these phases in the early 1600s, offering strong support for the idea that planets circle the sun. Occasionally, Venus passes directly between Earth and the Sun in an event called a transit, appearing as a small, dark circle slowly crossing the Sun's bright face. These transits are rare, arriving in pairs 8 years apart, then not again for over a century, making each one a truly special sight. Historically, transits of Venus proved especially valuable to astronomers, who used careful timing from different points on Earth to help calculate the distance between Earth and the Sun. Expeditions traveled great distances in past centuries, specifically to observe these brief, rare crossings and refine measurements of our solar system. Venus's brightness comes largely from its thick, reflective clouds, which bounce back a very high share of the sunlight reaching them. Even though it sits farther from Earth than our own moon at times, this reflectiveness alone lets it shine steadily enough to be seen easily without any instrument. Many ancient civilizations gave Venus a place of importance in their skies, weaving stories and careful calendars around its steady, predictable movements. Its consistent pattern of appearing and disappearing near sunrise and sunset made it a reliable marker long before written history began recording such careful, patient observations. Today, Venus remains easy to find for anyone simply glancing at a clear evening or morning sky, often mistaken at first for a low, steady star rather than a planet close in size to our own, wrapped in clouds and hiding a surface far different from anything we know at home.
As you rest here in orbit, imagine someone back on Earth glancing upward tonight, noticing this same bright point of light glowing quietly above the horizon, never once realizing that a ship and you within it are floating calmly just above its golden clouds this very moment. Part 10. Turning quietly toward home. The ship begins a slow, gentle turn, pulling itself away from Venus's steady orbit. Outside your window, the golden clouds start to shrink slightly, no longer filling the entire view as they did before, but curving gently at the edges as distance begins to grow between you and this bright world. There is no rush to this departure, only the same calm, patient pace that carried you here in the first place.
The engines settle into their familiar low tone, and the ship begins tracing a wide, gentle curve back toward the small, pale blue point that has been waiting quietly behind you. Looking back one final time, Venus glows steadily against the black, its golden clouds catching sunlight in every direction, hiding completely the volcanoes, highlands, and heated plains you have come to understand a little better tonight. From this distance, it looks softer than ever, calm and undisturbed. It is worth remembering, drifting here in the quiet dark, that this same golden light has been noticed by people gazing upward from Earth for many thousands of years, long before anyone understood what truly lay beneath those clouds, or how differently a single day could pass upon its surface. Venus offers a gentle kind of lesson, showing how two worlds, so close in size, can still grow so different from one another over time, shaped by atmosphere, by distance from the sun, and by countless small events stretched across a very long history within our solar system. As the ship carries you steadily onward, you may find your thoughts slowing along with it, matching the calm, unhurried pace of the journey itself. There is nothing left to do now but rest, letting the hum beneath you settle into something almost like a quiet, steady heartbeat. Ahead, Earth grows slowly larger in the window, its blue and white surface a gentle contrast to the golden world now fading behind you. Soon, this small, familiar planet will fill the view completely, welcoming you back after a long, calm stretch spent near our solar system's brightest evening companion. For now, though, there is only this quiet middle distance, one bright world behind and one gentle world ahead, with nothing around you but stars holding perfectly still and the soft, steady hum of a ship carrying you calmly home through the dark. Let your body rest here in this quiet stretch of space, wrapped in the low, steady sound of the ship and the calm knowledge that everything outside this window is simply continuing on, unhurried and patient, exactly as it has for a very long stretch of time already. As Earth grows nearer and Venus fades into a small point of light behind you, let this be a place to reflect, carrying with you the quiet image of that golden, cloud-wrapped world, and the calm reminder that even the harshest places can still shine so softly from far away. And on that note, we begin our slow return toward Earth, letting Venus fade quietly behind us into a small point of golden light. There is nothing left to do now but rest, letting the calm hum of the ship carry you gently through the last stretch of this journey. Tonight, we travelled far together, boarding a quiet ship, drifting through open space and settling into a calm orbit above its golden clouds. We looked past that brightness toward a surface shaped by heat, pressure, and ancient lava, learning what makes this bright little world so different from home.
We explored a thick, heavy atmosphere made almost entirely of carbon dioxide, a blanket so effective at holding warmth that it turned Venus into the hottest surface anywhere in our solar system. We also drifted through clouds built from sulfuric acid, the reason Venus shines so brightly in our sky. We considered mountains and lava plains hidden beneath that golden covering, from towering Maxwell Montes to the wide stretch of Aphrodite Terra, and we imagined volcanoes that may still be quietly active today. We also traced Venus's strange backward spin, where a single day outlasts an entire year. We remembered the many missions sent from Earth, from the patient Venera landers to the careful radar mapping of Magellan, each one adding a small, steady piece to our understanding of this challenging world. And we recalled Venus's gentle place in our own sky, glowing as morning or evening star. Let the images settle softly in your mind. Thick golden clouds, hidden volcanoes, a day longer than a year, and a bright point glowing steadily in our evening sky. There is no need to hold on to every detail tonight, only to let this calm sense of wonder rest alongside you. Space asks nothing of us except a little patience and a willingness to look upward every so often. Venus has been waiting there, bright and golden, for as long as anyone has watched the sky, and it will keep waiting after tonight's journey has ended and you have drifted off. Thank you for joining me on this quiet trip toward our solar system's brightest evening companion. Wherever you are resting tonight, I hope this slow journey through golden clouds and ancient lava fields helped ease your mind. Journey with me again soon as we drift together towards other quiet corners of our solar system. Each world holds its own steady wonders, waiting patiently to be explored. Until next time, keep looking upward.